Welcome to Podcast as Code, a show about the operations side of the software development lifecycle. I'm Mitchell Scott.
And I'm Gabe Cook.
Today, we're going to talk about serverless. And we don't have any updates or current events to cover, so we'll dive right into our main topic. Gabe, what does serverless mean?
So, at a high level, it's a way to host a server or a cloud service where you don't have to manage the server. Deep down, everything needs a server, but serverless, you don't have to think about it, like how much memory it has. Well, you sort of do, actually, but you don't have to think about, a lot of the like management aspects of a server and things like that. Like you more care about the code you ship, and then wherever you push your code, they manage the servers for you and the scaling and things like that.
How's that different from function as a service? Or like, do they share anything in common?
They're pretty similar. So function as a service is kind of like falls under the serverless umbrella, I guess. But it seemed to me like serverless is more just a general term of like not managing your servers, whereas function as a service is more like where you give them your code, kind of like I mentioned a minute ago. But there are different ways to do it. Like you also could use containers. Or I'm sure, there will be other things in the future.
Okay, so let's back up a little bit, I guess. In the as a service space, so we're talking about function as a service, which is actually pretty high up on the like abstracted list of services or things as a service. I think one of the only things more abstract would be just software as a service. But if you go down the other way, you kind of have so like software as a service at the very top, and there's a like an image and kind of a thought of talking about this kind of stuff, and it's pizza as a service. And I really like the pizza as a service. I think it's like version 2.0. And it talks about the different infrastructure-y things involved in like a pizza, various things about pizza, like pizza you make from scratch at home versus like a restaurant or like a take and bake type place. So we'll include a link to that in the show notes because it kind of helps explain the different pieces of like what do all these as a service things mean. But starting at the high end, so software as a service would be like, you use a piece of software that a vendor provides. You bring maybe like the user provisioning, and that's it. Function as a service is a little bit further down where you're bringing the code that runs the application, but you're not caring about much of the infrastructure at all. Containers as a service is like one below that probably because you have to care about the container builds and managing the container life cycles. And then below that is platform as a service, which I don't know if I've ever used anything that's purely platform as a service. So I'm not really sure what to compare that to. Below that would be infrastructure as a service, would be like EC2 or EKS. Yeah, you're renting infrastructure. You care about and provision things based on size. So like you're picking how much memory your nodes have, how much compute, disks, that stuff. Like you have to care about that. You don't have to go buy the actual like hardware, but you do have to provision it. Or provision the virtual hardware in a cloud vendor or something like that. And I don't know if there's anything below infrastructure.
Well, then there's like traditional on-premises deployments where there's no services.
Yeah, I think that's about it.
Yeah. That's a really good way to like simplify all these different acronyms that are hard to keep track of.
It is. And if you look at the like original pizza as a service, it's kind of backwards because infrastructure is like the last thing that it abstracts, which is not how the real world works with these as a service things. So that's why I like the pizza as a service 2.0. So if you haven't seen that before, give it a look. It kind of makes it make a little more sense and takes the buzzwordy stuff out of it because you can end up in kind of buzzword purgatory here pretty quick. So that's a little background on like all these as a services. So we can dive back into what is like function as a service versus I guess containers as a service fundamentally, but those things are both squarely in the serverless camp.
Yeah, so those are both serverless. You mentioned platform as a service. What sort of things do that?
Like Google's App Engine is the one I've seen thrown around as an example.
Okay, so I guess that's technically serverless too. You give them your code and you don't care about where or how it gets run.
Yeah, I'm not totally sure. I've never used it, so I don't
Interesting.
know what infrastructure things you have to pay attention to, if any. Yeah, it could be serverless.
Interesting. Okay. Cool. Yeah, I would definitely recommend. I think I'd seen the 1.0 for this, but not 2.0. It's a really good analogy.
Yeah, I like it. All right, so how do these serverless things work?
Traditionally, you create a server and you host your code on it, and then you have one server and you have to worry about auto scaling that server if you get a lot of requests or something. But with any sort of serverless hosting, you either give them code or a container or something like that, and they manage the server. They spin up instances as needed. They will spin down those instances if they don't get accessed for a long time too. So that's something to be aware of. They won't just have it sitting out there waiting for requests forever like a traditional server or a Kubernetes cluster or something would. So typically, I probably have the most experience in AWS Lambda. If you don't get a request within like 5 minutes, it'll spin down a worker. And so if you don't get any requests, then it'll scale down to 0 effectively. And so there's nothing there listening for requests. So it's a small downside to be aware of. The first request that comes in after, a long period of silence will have what's called a cold start time, where it has to basically initialize your code. And that typically is pretty fast. I mean, it's less than a second, but it's something to be aware of. It costs a little extra in billing. It takes time if you're loading a website. So cold start times vary depending on platform and how you're hosting it, which we'll talk about here in a minute.
Yeah, and you've mentioned requests a few times. How these are started or how these run they're typically request or event driven. So they're not things that run all the time. It's like it'd be like a website or something like an API responding to a web request
or a worker that pretty common use cases. You have data that gets thrown into a queue, and then the queue spins up serverless workers which handle some data and then maybe insert it into a database or save it to a bucket or something and then spin back down. So yeah, you're right. I should have clarified. A request, it could be an HTTP request. It could be any sort of event or a queued item or something like that.
Yeah, and I think most of these platforms will let you trigger on like a cron job. So if you do have something that like runs every hour or every 5 minutes or whatever, you can kind of get that working here too.
Yeah, you can. I mean, it's not a bad use case for maybe a backup service, which grabs your database and dumps it in a bucket or something like that, which you could run on a cron.
A lot of times they do have max runtimes. So that's something to be aware of.
Yes.
I can't remember. I think Lambdas used to be 15 minutes. You may be able to get away with longer now. I can't remember if they've changed that.
I think they used to be 1 minute and they've increased it to 15.
Oh, maybe 15 is the new one. So not a perfect fit for everything necessarily. So depending on a backup job, if it takes close to 15 minutes, that may not be the best use case. But if it's something fast and schedulable or driven by an event or a web request or anything like that, it's a potentially really good use case here and can be pretty cost effective. We'll talk more about pricing stuff later.
Yeah, so basically there are two ways to do this. In a lot of these platforms, at least, you can either just upload your code, usually as a zip file or from a bucket or something like that, or you can use a container. And there's kind of pros and cons to both. So just uploading the code is going to have a little bit less cold start times because they'll have that data already, replicated all over the world. Whereas if you use a container, that's not necessarily true. It's pulling a container from somewhere. So that's nice. You get the faster cold start times. You also don't need to build a container. You don't need to know how to build a container. You just upload your code. With probably the main downside being that usually there's a size limit. In AWS, that's 50 megabytes. So pretty big, but a code base can easily go over that limit.
Yeah.
And also, I don't know, that uploading a zip workflow is such a stray from the sort of thing my brain likes, honestly. We've talked about GitOps a lot. I like preventing configuration drift and things like that. And just uploading a zip file where you have a cloud IDE editor really doesn't lend itself to preventing any sort of config drift.
Yeah, it kind of goes against the, I'm used to containers. So like if a dev has built an application in a container, I know that same container is going to run just fine in production. Whereas if you're dumping zip files full of code around, I'm a lot less confident that that's going to run exactly fine the first time. It seems like there may be some finagling there to get code running in production, like in one of these function as a service platforms, the same way it's running on a developer's laptop, for instance.
Yeah, so that's actually, I prefer using containers for these, even with the added cold start times and things, just mainly for that reason. Even though there's some small downsides, you build a container with a specific version of your language, and that's what you're going to get. Whereas if you're, uploading a zip file, usually there's a drop down that's like, which node version do you need? And actually, that's another downside I didn't think of before now. You have to be running one of the languages and one of the versions that they support. And those get deprecated and things like that. I mean, you want to, you want to stay on newer software if possible, but like there are times where you can't necessarily upgrade to node, 18 when AWS says you have to. So the container gives you the freedom to build whatever you need and ship it serverlessly.
Yeah, and another thing could be you may have been given a container by a software vendor and you may not have the source code. Like it may not be an open source project.
That's true, although
I guess you could get binaries though, because those function as a service platforms, you can build and upload binaries if they support the languages, right?
Yeah, well, and usually there's some tooling that you need to have within the container. Like there's specific Lambda libraries that you need to install. So I don't think you can necessarily just run anything there. Although I have seen some command line utilities that can let you do that sort of thing. Like when I was first deploying some Go apps serverlessly, I tried a few different methods. They have an official way, and you basically write what they call a handler for Lambda. But the problem is I couldn't run that locally because I wrote it specifically for Lambda, not just HTTP. So I started looking into those alternatives I mentioned, so I could just write an HTTP server and then point that, that same container on my local machine and on Lambda. But then I found they have this binary that basically, translates a local HTTP request to what Lambda would do. So maybe you could use that sort of thing. I'm not sure. But yeah, that's a good point. Containers give you a little more freedom. So they're very similar to your local environment. You're just deploying a tag. You can't change the code in there. So that kind of prevents code drift and configuration drift. And you can also just go in and check the image tag. So it's really easy to see which version of an app is running, for example. Whereas if you just had a zip file, hopefully you have maybe a copyright header, which also has a version number, but that's not guaranteed.
Oh man, that sounds horrible to me.
Yeah, I know. I know zip is like theoretically faster, but I just like containers. Might just be me though. I am a little crazy. Not everybody listening will know, but I use Docker and things so much that a lot of times if I find some tool online and I don't know if I'll use it all the time, instead of installing it on my machine, I just spin up a container and install it in there.
Yeah, Gabe just today refused to install PowerShell on his MacBook when we were troubleshooting something.
I mean, I could just run it in a container. I don't have to install it. I don't know. I love containers, even though they have some extra like cognitive requirements to deal with them, and it can be exhausting. I do it to myself. I don't know.
Yeah, the other thing about containers, like in Lambda in particular, it is a little bit newer. Like I think they introduced that in 2021 or around there. So it is a little newer. There aren't as many tutorials and stuff out there on how to, do XYZ thing in Docker with a Lambda. So that is one thing to be aware of.
That's true. If you Google, how do I deploy a thing to Lambda? All those guides are probably zips. How to upload your code. You're right.
Yeah. So we've already mentioned one of the platforms, which is AWS's Lambda. That's what they call their function as a service and kind of their containers as a service offering.
Yeah, they just call that one Lambda containers. So it's still Lambda.
Yeah, the other cloud vendors have them as well. GCP has Cloud Functions for the function as a service, and they have Cloud Run for containers as a service.
Yeah, and those are pretty similar, right? Like Cloud Functions is a lot like Lambda, and then Cloud Run is a lot like Lambda containers.
It's weird because I've only used Lambda with containers, and I've only ever used Cloud Functions in GCP to write some like little alert stuff. So I haven't used like the actual comparable pieces of them. So I'm not totally sure.
I think that they're similar, but I'm not sure. That's interesting. I've used both Lambda types, but I've only used Cloud Functions, I think. I don't remember now.
And then Azure has Azure Functions, which seems to encompass, kind of like Lambda, both zip, upload your code type stuff and Docker-based container runtimes.
Yeah, I've never touched Azure Functions, but
I have not either.
Probably pretty similar.
I haven't messed with Azure in a while.
So AWS created Lambda. I think that was by far the first serverless, platform. I mean, I'm sure there were more things before that, but that's the first one I'm aware of and the first one that kind of like coined the term and became a big thing. So it does feel like a lot of them are similar just because they're based on, what Lambda started out as and then iterated upon. And lastly, there's one which is a little bit different because it's not provided by a cloud vendor. It's an open source project, but it's a pretty cool tool. So it's called Knative, and it's written for Kubernetes. It runs in your cluster and gives you similar functionality. I know if you're running a Kubernetes cluster, it's not necessarily serverless, but it's cool because it allows you to host serverless workloads, for customers or for other people. And it helps to save, memory and CPU within a cluster if you have some service which is rarely ever used. So Knative is pretty cool. It's a little bit different. It requires different ingress controllers. Like you can't just use Ingress and Nginx with it. So most of the controllers it uses use the new gateway API, which
interesting.
It's very different. So I don't know much about it. They do have one called Courier, which is basically an ingress for Knative, and it uses the typical ingress things, but
that makes sense because you would need the ingress controller to spin up the workload pods. So I get why you would need some integration there.
The main difficulty they had was because of the cold starts that we mentioned, or if you only have one container and you get 1,000 requests at the same time and you need to spin up another one, you need the ingress controller to hold on to the request. Like it needs to come in and be held until a container's ready, and then it can continue flowing like normal. So most ingresses don't support that sort of thing.
Oh yeah, because if the backend service doesn't have like a pod attached to it, it'll error out up to the ingress controller, right? On like a typical ingress controller.
Yeah, I guess it would just give a 502 or something like that. Yeah, so it's a little bit different. You need one that can hold it and spin up a container and wait for that cold start time before it can basically replay the request against the running container. So it's very interesting.
So you mentioned that like this is not really how you do it in a cloud vendor, but Cloud Run, like at GCP, is using Knative behind the scenes. That's how they're doing. That's how they're running the Cloud Run workloads themselves.
Oh, nice! I didn't know that. That's really cool. I mean, it makes sense. It's a solid project. I used it here at my house for a while, so I mention my cluster at home quite often. But At first, I didn't have near enough memory for all of the apps that I wanted to run here at my house. So I actually used Knative for a while for a lot of the apps that I rarely touch, but are nice to be available when needed. It was cool to be able to spin them down. Knative also lets you set a minimum and maximum scale, which is nice. So you don't have to scale to 0 and fight cold starts. So honestly, it's kind of a cool way to just solve auto scaling in Kubernetes. But still, it's, very different paradigm, and it's a tool you have to install. So sometimes it's nicer to stick to the built-in functionality. But it does feel more, I don't know, it feels less reactive than traditional auto scaling. Like auto scaling in Kubernetes, you typically watch like CPU usage or memory usage. And if they hit, 80%, then you scale up. But that's very reactive, and it's going to be a little bit behind. Whereas Knative, you configure how many concurrent requests a pod can handle. So you say, okay, give like 500 requests at a time to pod number 1. Then if you get 600, 500 will go to one pod, then it'll spin up another, and 100 will go to the next pod. So it's more proactive, at least.
Yeah.
I don't know. But it's a cool project.
It is, and it's about the only way that I know of to get this sort of thing for an on-prem environment. So if you have servers on-prem, and you have people who want to consume your services and just want to give you a container and to run it when web requests come in or whatever, this is going to be a way to do that with your on-prem infrastructure you may already have, which is nice. It's a valuable service you could offer to, either internal or external consumers of your infrastructure.
Yeah, because it just vastly increases the number of apps you can host within a cluster. Like if you have 4 gigabytes of memory and you have 4 apps which take, a gigabyte, like that server is full. If they're running 24/7, that server is full. But if one of those aren't accessed very often and you use Knative, it could scale down.
Yeah, I could see you using this to squeeze more applications, more workloads onto a multi-tenant environment for sure.
Definitely. Yeah. To save some costs. And man, I did not realize Google was using it for Cloud Run, but that is like a huge endorsement if an entire cloud vendor uses this in production. That's cool.
Yeah, and to be clear, that one is not function as a service. It's pretty firmly in the container as a service camp.
Yeah.
What workloads lend themselves to this? It seems like websites or APIs would be perfect.
Yeah, although you have to be aware of the cold start time. Sometimes that can be a problem. But yeah, it's a great use for like small APIs or something like that where it's okay for the data to be slower. I'm more hesitant to recommend a website unless you have good caching in front, just because a slow web page is annoying, but a web page that loads with a low loading icon, at least to me, seems less annoying. But yeah, I think it's a good fit for, web hosting, worker type things that I mentioned, something that ETLs data or inserts it from a queue. Typically stateless workloads. So nowadays you can mount file systems, sort of, but it's the more stateless workloads that you want. Like you wouldn't want to host a database here. You would.
Oh, that sounds horrible.
Yeah, no, you can't. There's no way. I mean, I'm sure it's theoretically doable, but don't try it. Nobody try it. That sounds very unfun.
If you spin up a pod per insert or select, it'd be so fast.
That sounds horrible.
No, and that one you built was like a perfect use case for these. Do you want to talk a little bit about how you did that or what the design of it was? Because you mentioned a queue.
Yeah, so I've actually written quite a few different serverless workloads so far. They've all been in Go. I'm a huge fan of Go. It works really well in a serverless environment. So we needed to make an application which could ingest basically like a spray of sensor data. And we needed the service to always be running, always be available, not go down for server maintenance. And that's a perfect use case for Lambda. I set up this service so that I could ingest the data using Go and do some transforming and put it into a format that we needed it. And then data could be pushed to SQS.
And that was from the sensors or the in-field devices directly,
yes,
right?
Sorry. Yeah, the devices would hit SQS's API to push data. And then SQS would trigger a Lambda to ingest it. And actually, it could handle a lot at once. I did some like load testing of it, and I could push thousands of messages to a single Lambda at a time. So typically you just get one, but also, that's configurable, which was really cool. You could say one Lambda instance per message, or one per X number of messages. So then the Lambda would ingest the data.
Where were you batching those at?
What do you mean?
Weren't you batching those? Or only letting it run like once a minute or once every 10 seconds?
Yeah, that's what I'm talking about. That was with SQS. You can configure how many messages it should hold for how long before it spins up a Lambda and spits all of them over at Lambda. So yeah, and then it would just ingest the workloads and insert them into the database. This was a really cool workflow though, because it gave us a lot of freedom. Normally, this sort of thing would be kind of scary and fragile, in my opinion. Like, I would be scared to upgrade the Kubernetes version because we would lose data for at least a few seconds, maybe a few minutes, maybe a few hours if it goes awry.
Well, and we had another project that did similar sensor ingestion type things, and we didn't use a serverless like workflow for it. And we had issues. Like, we had to be very careful with how we did infrastructure work or database upgrades.
Yes.
Because we had to make sure that data was flowing somewhere all the time, even when we had to do like critical maintenance. Whereas with the serverless workflow with the queuing in SQS, even if the Lambda, like if something breaks, like if we push bad code and it fails to start up or whatever, it's still, that data's still getting queued, and as soon as you fix it, it's going to plow through the queue and you're going to be just fine.
Yes. So SQS is a service provided by AWS. It's out of my hands. It has really good uptime though. So, if you can push these whatever records directly to the SQS, then it has what's called a dead letter queue. So yeah, like you said, if the database is down due to maintenance and the Lambda fails to insert, it'll trigger an error, and SQS will push the record over to a dead letter queue where it can expose that to us and notify us, and then it'll retry later on. Or yeah, if I just push bad code that doesn't even run, same thing. It hangs on to that and retries occasionally with an optional notification. So like there is no chance you lose data, which is awesome. So yeah, it worked really well. It felt like, honestly, kind of the perfect fit for Lambda.
Yeah, I agree.
It was a lot of fun, and it was really a relief to be able to just like upgrade a database version without caring versus, having to be very, very careful, which is how I think it should be. Less concern with what exactly is running. It's all high availability and things.
Yeah, it's just that extra layer of abstraction can really make your life easier.
Mm-hmm.
So with that, let's talk about some of the pros of serverless. We'll keep it higher level. We kind of talked about the pros and cons of function as a service versus containers, but serverless in general, like, what are some pros to that?
It can be very cost effective. Since you're not paying for a server 24/7, you pay for like the milliseconds that you used it. So if you have a quick running service, it can be very, very cheap.
Yeah, like that service you built cost like, I don't know, that month we looked at the usage, it was like cents, wasn't it?
Yeah, I think it was like 30-50 cents a month or something like that. And that was with constant data ingestion, which is really cool. I had used ARM for that too. That's one nice thing. ARM runners are even cheaper, and they use Gravitron, which is a great CPU class. And
then kind of like I said, the extra abstraction over infrastructure as a service and platform as a service is nice. You don't have to really architect in much high availability. It's you kind of get it for free.
Yeah.
If you're careful about how you design, how things get to your serverless functions or containers, then, and as long as those things can run in parallel without having to talk to each other, then you basically have scalability and high availability kind of built in, which is super nice. Because that stuff's kind of hard to architect by yourself from scratch.
Yeah, typically it is. Whereas like this is very simple to deploy. Like it'll just scale for you, and deploying it is like providing a container or uploading some code and you're done. And that also lends to a big con though. So that infinite scale means that pricing is pretty hard. It's very different than your traditional server where, you deploy a server which is $30 a month, or even in Kubernetes where you have, a cluster which is 75 plus, 3 servers, which are again, whatever, $30 each. This is pricing down to the millisecond based on how much memory you're giving the service. So it's easy to mess up pricing. At least AWS, it's nice 'cause they give you like the first like million requests and a certain amount of gigabytes of memory for free. That's under their forever free tier.
Yeah, the pricing's kind of hard to predict, especially for a net new service that you don't know what its traffic is going to look like or how often it's going to be hit. It's hard to predict.
Which is why the free tier's nice though, because you can see.
That is nice. But and then you also have the issue of like your cost is kind of unconstrained and therefore at the mercy of like who or whatever is hitting your service. Where if you, like you said, if you've got a Kubernetes cluster, unless you have some crazy auto scaling hooked up, like if you get denial of service, you're not going to pay anything more for that. But if your serverless function gets hit and is running all the time, like that's going to get very expensive for you.
Yes. And you can set limits, but they're a little less guaranteed than other services just due to the nature of, how quickly it's responding to these requests. But you can set like soft and hard limits. But yeah, you're right. You have to decide under a lot of load, do I want my site to possibly go down or do I want a large bill and just something to plan for?
Yeah, we kind of touched on cold start time earlier, but the startup time for these are measured in the tens to hundreds of milliseconds for that first request. And then the service provider will like suspend them for a little bit of time, like a few minutes. And then after that, they'll spin them completely down. So you have a bit of a phased and not super guaranteeable response time curve to these things.
Yeah, it's less predictable. And then there are those time limits. So that has been raised. 15 minutes is quite a lot of time, but still, if you're doing a huge database backup, or I mentioned earlier, if you try to batch too many messages, it might go over the time limit and then that'll show up as an error. So it's something to be aware of. It is a limitation, which can be annoying, but there's no way around it.
Yeah, I worked around that in a stupid way one time. I had a couple of tasks.
Oh, apparently there is a way around it.
Well, I had a couple of, I think this was before the 15-minute increase. So I had something that would run and it took close to a minute I don't remember what it was doing. It was going out and like, I do know what it was. It was downloading Tableau server versions and hashing them to compile like a list of checksums because Tableau didn't provide them for us.
Oh, that's cool.
And those downloads took a long time. So I couldn't download all the versions in 15 minutes. So I had to like parallelize them in a weird way.
I mean, that makes sense with Lambda though. Anyways, I've done similar things. I think it would make sense to like have one, which is a starter process and it kicks off a Lambda per Tableau version and then waits for all the results.
Yeah. And then another thing I did was like a Lambda that grabbed something, put it in a bucket, and then the act of putting it in a bucket triggered another Lambda to run another job because the first job ran close to that minute timeout. So it kind of did like a staged like approach to doing something where it would have been it would have been easier to do it all in one like container, but this was pre-containers and pre that longer timeout.
Yeah, although even with that timeout, you sometimes have to work around it. I've had to do that once. I set up a workflow which basically gave a Swagger UI hosted by Lambda, and it was for a environment hosting a bunch of WordPress sites, and they needed to mirror prod WordPress instances back down to staging or dev sometimes. And so it would give it, there was a Swagger UI that would give all of their WordPress sites. They could choose one, choose where to import it, and click a button. And so that UI was served by a Lambda. When they clicked the button, it would kick off another Lambda, which would actually do the database work. And the reason I had to use two Lambdas like that is because there's this weird limitation in load balancers in AWS where normally you can send a lot of data and set a high time limit, but in Lambda, they're hard coded. I can't remember the specifics now, but like the file download size was too small. So I had to upload the file to a bucket temporarily and give a download link. I think you can only do, I don't remember the number, like 10, 20, 100 megabytes, but it wasn't enough.
I think the Lambda's ephemeral storage is pretty small too. And that's kind of the thing is like, if these work for you and you don't have a lot of weird constraints, they may fit really well, but you do have to play within kind of the confines of the rules that you're given. And you get a little more leeway with the like container-based ones, but still, these only fire up when they receive an event in the way they expect.
Yeah, and I learned about a cool Docker command because of these. Apparently, you can run Docker pause on a container and it like freezes it in memory, and I don't doubt that's what they're doing here. So yeah, you outside of the time that you get a request and you are responding to that request, you cannot do work. It is frozen. And I just had to Google it to check. I was remembering much more optimistically. When you use a Lambda function as a target for an application load balancer, the download size limit is 1 megabyte, which is just small.
It's tiny.
So yeah, I had to work around that. And then another limit just to be aware of is like storage can't always be mounted multiple places. Like in AWS, for example, like I'm very used to mounting EBS volumes to EC2 instances, but that's not possible with Lambda because EBS can only be mounted to one target at a time. So you can nowadays use EFS with Lambda, but EFS is, very different than EBS. So it's something to be aware of. Also, just due to the nature of scale, if you have a service which needs like SQLite or something like that, it's not really possible to host it there, which is unfortunate.
Yeah.
But I've seen some tools that supposedly do that sort of thing. I'd like to try one out because there's an open source project.
Oh, really? Like database-y type stuff?
Yeah, for SQLite specifically.
Interesting.
So there's an open source Go project I really like called Pocketbase, which lets you create an admin site and Go with minimal effort. It's awesome. But they're working on adding more database support, but currently it only supports SQLite. So I want to host, my personal portfolio site uses Pocketbase, and I want to host that in Lambda, but at the moment I cannot.
Yeah, don't use EFS for SQLite because EFS is NFS, and SQLite will behave like it's on the other side of a dial-up line.
Yeah, SQLite doesn't like NFS. But yeah, if I end up liking one of those projects, maybe we should talk about it someday. We'll see.
Yeah. If any of our listeners out there have done anything cool with Lambdas, we'd love to hear about it. Our website is podcastascode.show. If you have cool Lambda stuff to tell us or have topics you'd like us to cover, send us an email or hit us up in Discord. Our email address is contact@podcastascode.show, and our Discord invite link is in the show notes. Join us in a fortnight for an interview with a tech CEO.
See you next time.